Chapter 15, question 14. Identifying individuals with a high risk of Alzheimer's disease usually involves a long series of cognitive tests. However, researchers have developed a 7-minute screen, which is a quick and easy way to accomplish the same goal. The question is whether the 7-minute test is as effective as the complete series of tests. To address this question, Ingen and colleagues, 2008, administered both tests to a group of patients and compared the results. The following data represent results similar to those obtained in the study. So we've got patients A through I, and the 7-minute screen we'll call variable X, is 3, 8, 10, 8, 4, 7, 4, 5, and 14. And then for variable Y, the cognitive series, 11, 19, 22, 20, 14, 13, 9, 20, 25. The first question, A, asks, compute the Pearson correlation to measure the degree of relationship between the two tests. B, it asks if it's significant or not. And then C asks for the percentage of variance predicted. I'm going to compute the Pearson correlation, which is technically step 3 of the hypothesis testing procedure. And then for part B, I'll go back and I'll do step 1, step 2, and then step 4. So for step 3, what I want to do here is I want to give an example of using the computational formula instead of the definitional formulas. And so the first step is that we need to calculate the sum of squares, which is true regardless of what type of formulas we're using. The sum of squares formula, the computational formula, is the sum of x squared, subtract the sum of x, that is then squared, divided by n. So what we need to do is we need to calculate x squared. So we need to take all of these x values and square them. So 3 squared is 9, 8 squared is 64, 10 squared is 100, 4 squared is 16, 7 squared is 49, 5 squared is 25, and then 14 squared is actually 196. So we need the sum of x, we need the sum of x squared. Sum of x is equal to all of these values added up, which is 63. The sum of x squared is all of these values added up, which is actually 539. And so we can calculate the sum of squares of x. So we're going to take the sum of the x squared, so 539, subtract the sum of x, 63, squared, divided by the number of values we have, which is 9. So we have 539, subtract 63 squared is 3,969 divided by 9. So we have 539, subtract 441, which is 98. And if we had taken each x score, subtracted the mean, squared it, and then added it up, we would get that same value. So if we use the definitional formula, we would get the same value as with the computational formula. They're equivalent to each other. We need to calculate the sum of squares of y. So we're going to take each of these scores and square them. For brevity, I've already calculated this through. Also to reduce the likelihood that I make an error and have to restart the video. Don't have time to restart videos right now. So now I'm going to do the sum of y. So adding up all of these values gives us 153. We also need the sum of y squared. So adding up all of these values, and that gives us 2,837. So now we can calculate the sum of y squared, or the sum of squares y, sorry, sum of squares of y. So we're going to take the sum of the y squared, subtract the sum of y that is then squared divided by n. So 153 subtract 2,837 squared. There's something wrong there. Ah, yes, that's not this. Sum of y squared, sorry, my notes are messy. Keep your notes tidy. Nope, that was right. Still keep your notes tidy. What I've done here is I've mixed up the sum of y and the sum of y squared. So what I need is actually 2,837 subtract 153 squared divided by 9. Doesn't matter how many years you've been doing this, you need to keep things organized and double check your numbers just in case, because mistakes happen. And that's why it's also important, it's really important to show your work so that if you do make a mistake on homework or on a test, your professor can see where you went wrong and give you guidance on how to correct that mistake. If you don't show where you're making your mistakes, then it's really hard to help you fix your mistakes. So 153 squared is 23,409. And we still need to divide that by 9. We need to calculate the sum of products, which is where I started to get myself confused because my notes are not as clear as they probably should be. So we're going to take each x score and multiply it by y. So we're going to take 3 times 11 and we get 33. 8 times 19 and we get 152. And we do that straight down. And now we'll also need the sum of x times y, so we need to add up all of these values, and that is 1,198. I have a bit of space down here. I'll do it right here. So the sum of products is the sum of x, y, so this value, subtract the sum of x, which is over here, times the sum of y, which is right here, divided by the number of scores. So 63 times 153 is 9,639 divided by 9. So our sum of products is 127. So what we need to do now is we need to calculate our R. So R, the Pearson correlation, R is equal to the sum of products divided by the square root, the sum of squares of x times the sum of squares of y. So the sum of products we just calculated was 127. And underneath the sum of squares of x was 98. The sum of squares of y was 236. So this is 127 divided by the square root of 23,128. $152.079, which is 0.835. So now for part B, I'm going to go back and do the other steps of the hypothesis testing procedure.